Welcome to DJ Tutorials Primers. This is part two of Understanding Your Computer. If you haven't taken a look at part one, please do so that this video makes a bit more sense to you. Now, let's talk about the GPU or graphics processing unit. This is your graphics or video card, and some CPUs have what's called an integrated GPU, and they have their place in working situations, and a lot of people with laptops or Apple products will probably have something like that. This is a example of a CPU that has an integrated GPU in it. Right here, the Ryzen 5 3400G has what's called the Radeon RX Vega 11 in it. So this one in particular, it says right here graphics specifications, and it tells you what kind of graphics card is in there, what the frequency of that graphics card is, which I'll go into in a minute. But really, for a lot of the people who will be going through the tutorials that I'm doing, an integrated graphics card is okay for very beginning work and getting to know the interface and things like that. I worked for 6 months on a laptop that had an integrated graphics card, and it was very, very difficult, but I was able to get it professional stuff done. It just takes a long time. So I will not really be going over a lot of integrated graphics cards. I'm going to be going into the larger cards, also called discrete video cards. Since we're primarily going to be talking about the much larger discrete GPU graphics cards, the main contenders here are going to be AMD and NVIDIA, also known as Team Green for NVIDIA, and then for Radeon, Team Red. So these are really the only two companies that are providing graphics cards at this time for what we need. And there is talk of Intel, uh, the CPU manufacturer, creating discrete GPUs to get involved in the scene. And if you look at their website, they really don't have anything on this yet because it's such a new concept and they haven't really released it yet or anything that's um, a really good idea about what it's going to end up being. They release their information through news channels like this WCCF Tech has a news article about the discrete GPU that they're looking at releasing. And depending on when you watch this video, this could already be released. So there may be a Team Blue in the future, but as of right now, we really don't know what this is going to look like and how affordable it might be for people like you and me. But it's out there, and it might be a good alternative depending on the price point and how well it performs. When we're looking at discrete GPUs, there's really two sort of grades that I would say matter. And on the NVIDIA site, you have the GeForce and the Titan, which really these are kind of in the same area. This is a much higher end graphics card for gamers, but it's also for content creators. And but it's a much cheaper price compared to the Quadro professional graphics cards. So that's really the two tiers. So you have your gamer, mainstream, or consumer brand, and then you have the professional. And the real difference between the two is price, driver, and support. Price between the two, it's basically night and day. You're going to pay much more for roughly the same sort of components that are inside of, or the same parts that are inside of these professional cards than you will on these consumer based ones. And you can often get the same, if not better, performance out of a mainstream or consumer graphics card than you can a professional card. The really, really big difference is the driver support. So, the driver is the actual software that runs the video card to make sure that your fans on the card or the cooling systems are working properly and that it's optimized for software. And there are some professional optimizations inside of the professional drivers that make certain programs work better than others. And also the driver support, meaning people you can talk to. There are individuals you can speak to about any sort of issues that you run into. But for most of us who are going to be working on this channel or working through the tutorials here, you do not need a professional graphics card. In fact, I would recommend you stay away from a professional graphics card unless you have a lot of money to spend. And NVIDIA is not the only one that has this. If you go over to AMD's Radeon, they have their standard sort of gaming uh, GPUs. And if you go up into the Graphics Pro graphics and go to here, they have their own line of these as well that look very similar to that, what that Quadro looked like. So let's now dig deep into what these graphics cards do and what the specs actually mean when we're looking at them. So I'm going to open up because I have this card, so I know a little bit more about the Radeon 7. I'm going to open up this. I actually have two of these. So just like we went over briefly with the CPU, they do have a certain sort of size of the transistor, which is what this means. But really, that doesn't matter as much as other specifications for these particular components. So we're going to go down to where it's more. There we go. So this is really the specification. So again, most of this doesn't make any sense to you, so I'm going to do my best to explain to you what all this stuff is. So at least most of it. I'm not going to go that deep into compute units and all this other stuff, really. I'm going to talk about some of the main stuff that matters. So if we look at the frequency, it's the same thing like the CPU. You will generally have what's called a peak or boost frequency, and that's usually the advertised frequency. And it's in megahertz here, and then you'll have a base frequency often. Even if they don't tell you, because NVIDIA, I don't think actually shows you the base. Yeah, so see here, they just show you the boost clock, 1635, 1650, but they're not telling you what the base clock speed is. So this one actually tells you we have a base frequency of 1400, and it can go up to 1800 under large or heavy load. The next thing that we're going to look at, sorry, this is the boost here, and then this is the peak. So this one actually tells you three different frequency ratings, but really it's going to be somewhere around 1750, provided you're not overclocking your card, which that will be covered in a later tech video. The next thing that we're going to be looking at as far as what's important to you is the requirements here that talk about the typical board power. Okay. What this means is that when this is put into your system, you need to be able to provide 300 watts to this component. Now, that is a very, very high number of wattage for a GPU. This particular GPU is more of a what's sometimes considered a prosumer GPU. So it has higher higher needs because it has a lot higher specs than other GPUs. But that is a lot, and it needs basically a certain number of cables with a certain number of connectors to be plugged in into your desktop computer. Now, most of you, if you're purchasing your own computer from a manufacturer, they will already take care of all this stuff. So you don't have to worry about whether or not you're going to have enough power. But if you were going to install a new video card or exchange one or anything like that, you just need to know that you need to have 300 watts available to plug this thing in. And right here it says the PSU or power supply, which we're going to talk about later, recommendation is at least 750 watts. So that's what the typical board power is. That's how much wattage under really heavy load is going to be used, and you need to be able to allocate 300 watts to that GPU. The next thing we're going to talk about is the memory size. Now, the memory size is also called VRAM, VRAM, and let's see if they call it that on the NVIDIA page. They call it GPU memory size as well. But this is generally called VRAM. And what it means is the video random access memory. And it basically is talking about how much information can be stored within the video card to be read. Generally, the higher the memory size, the better for buffering 4K or 8K video and also rendering high complex scenes with a lot of really high complex textures in it. So, the gigabytes of VRAM or memory size is really, really important because this is going to limit what you can or cannot render inside of Blender. My recommendation is to always have, or as much as you can, get something with at least 8 gigabytes because 8 gigabytes will usually handle 4K renders just fine. without huge fall off in efficiency, and you'll be able to have a decently complex scene with the 8 GB of VRAM. So when I'm making my recommendation on the type of video card you should have, and I recommend having 8 GB of VRAM or the max memory size, obviously this is going to depend on your pocketbook and how much you can spend. I would say that it would be much m- better for you to get an older card that is 8 gigs of VRAM rather than getting a brand new one that's only 6, specifically because of the limitation. Now, the older one won't be as fast as a newer one with 6 gigs of VRAM, most likely, but you'll end up with less limitations as far as the size of the file you can render and the types of textures and materials you can have in your scene. And just to give you an example of what I'm talking about, if I go into the NVIDIA site and I look at the GTX 1660 Ti, which is a kind of like upgraded version of their regular 1660, and you look at the size is 6 GB here of VRAM. So that's lower than the 8. So again, not recommended from me if you're going to be doing stuff professionally. I think that you do need a little bit higher. If we take a look at Amazon for an older uh, GTX 1070, right here we can see there's a Zotac GeForce GTX 1070, which is the last model design that they did, which is actually a really great card. I have one of these. Not in my current build, but I do have one. And it's 8 GB of VRAM. So this one is, it says right here, this is a mini, so this is one of the cheaper ones. It's really small. 219.85, and then the TI is 279. So you can see right there, you do have a little bit of a price difference here. In the two, for the older one, you can find some very expensive 1070s out there still because it's such a great card. So, just keep that in mind. But in general, I would say that if you had the choice between the two, go with an older 1070 over the new 1660, if you have a choice and if you are able to do that. GPUs have a variety of cooling systems, each with their own positives and negatives. There's fan or open cooling, blower, all in one hybrid liquid, and open loop liquid cooling. Fan cooling, or sometimes called open cooling, is similar to CPU fan cooling, which means there's basically fans and heat sinks. And this is basically the way that gaming cards are done nowadays. And on the AMD Radeon website, and I love this because I have this card, so I know a lot about it, but this really does separate everything out so that you can kind of see what goes on with the graphics card. So the card is actually this section right in here. That's where the card sits, and it's on the circuit board. And then there's a series of cooling mechanisms. So here's the heat sinks. You have a kind of like your heat pipe system. It's just this plate here that sends the heat up this way, and then you have a series of fans that will blow air around inside of the case, so that you can dissipate the heat. The outside part of this is called the shroud. So, you'll have people trying to sell you on, a GPU because there's a black or red shroud, which is kind of weird. Um, so, but anyway, this is really cool because there is this little, it's actually animated as you scroll down. So it shows you how it opens up and what all of the components are inside of there. So this is kind of the basic. This isn't actually basic. This is more of a high end graphics card, but this shows you a basic breakdown of what goes into this type of cooling system. Now, if we look at Newegg, which is a great resource for purchasing computers or just purchasing components and all that, you'll see that there's in the video card section, there's all these different types here. So the open or fan cooling systems are the ones that look like this, where it's really obvious. You can see the big fans on the top, and you can kind of see the metal. I'm not sure if you can see it, but let's just pick one of these here, open it up, and you'll see the fan, and you see the heat sink right there with the heat pipes and everything. So this is really the main video card that is being produced with this cooling system today. So, lots of them, so many will make your head spin on how many different models there are, how many different fan systems, how many different shrouds. all that kind of stuff. It's really, really crazy. So when you are purchasing, you really need to pay attention to the reviews. Uh, Often the one that looks the coolest is not really the best one. So you really need to, or the most expensive for that matter. Um, you really need to look at the reviews and make sure that it's really going to match what you need for your type of video card and that the cooling solution is going to work. Now, for most of you watching this, you're going to be brand new to this. So most of you won't have that much of an option on what type of fan or cooling system is going to be on your GPU. But most likely, this is what you're going to get. You're going to get some form of cooling system that looks like this. The next type of cooling system is what's called a blower style. And these are kind of the best ones to kind of show you because these are professional workstation GPUs, and these are what they usually come like for the following reason. How this works is that this little fan mechanism here will spin and blow air through the card and shoot the hot air out of the back of your computer. So this is actually on the back of your computer. And when you are stacking multiple GPUs inside of either a server or you're putting it inside of your own computer, having the air blow out the back is a better alternative to the fan based system like this because what it basically does, let me get to where you can kind of see the card not blown up. If they even have it, let's just open up a different, we'll just look at this one here. With this card inside of your system, it's going to blow that hot air all around inside your case. And if you have a whole bunch of these, let's say 4 stacked on top of each other, they're not going to be able to get the cool air they need to cool off the card. And they'll basically just be circulating. If you don't have a good enough airflow inside your case, they'll basically just be circulating hot air and eventually will overheat your cards. And that's why these are preferable to systems like that. Now, blower style GPUs tend to run hotter, they tend to not be as fast, and they tend to be louder than the fan based cooling systems, but they have their own place when it comes to workstation graphics. Now, case design is getting better in regards to the fan based systems for cooling. And if you get a really, really well built, high air flow case, maybe you can have a bunch of fan based ones like I do. But even for the one that I have, it's preferable to have at least 1 or 2 of the video cards in there as a blower based model, simply so that you can keep the CPU and the GPUs from getting overheated from the amount of hot air circulating around inside your case. So, again, they have their own place. They are good for certain things. Um, and they tend to be a lot cheaper. So, it just depends on really what you're trying to get. The next one that I'm going to be talking about, which we can actually view on the main page here, I believe, right down here towards the, not so much the bottom, but over here on the right, you will see basically these hybrid models. And basically, how these work is exactly like the CPU, where you have a liquid uh, cooling system that's built into the card. So it has a fan that's on the card, and it also has this liquid cooling sort of like hybrid approach. So if you're the kind of person who really is going to overclock the heck out of their card and you need it to run super quiet, you may want to get something like this. But because you have this extra radiator and fan setup, you're really removing a lot of, or you're taking up a lot of space inside of your box or inside of your case. So and they're also much more expensive. So if you look here, $1,900 for this particular type of system for this model. And if we quickly go to the NVIDIA site, here's a 2080 Ti right here, $1,200. Okay, and the liquid cooling sort of hybrid one here for this EVGA branded RTX 2080 Ti is 1900. So again, if you really need something like this and you're an enthusiast, maybe this is a option that you might want to go with, but I really would not recommend this. Again, it's one of those things where, you know, 1200 compared to 1900, you could basically buy another graphics card or more RAM or a better CPU or something like that instead of getting this type of card. So I do not really recommend this sort of setup for most people. If you're the kind of person who has a lot of money to spend or you need something like this, and I put need in quotes, fine. I'm not judging you, but I do not recommend this if you're trying to be budget conscious, and you're really not going to get that much out of it. Uh, like adding a second card would be a lot more of a frugal buy than buying one of these. So that's the hybrid system here. Now the last one, again, showing you this same one from the open loop system for CPU cooling. This is also for GPU cooling. So that right there is a GPU that is on a water block. And um, generally, I really wish that some of these things weren't in the way here so that you can see what I'm trying to show you. But basically, if we just kind of look at this image here, if you need to use your imagination, I apologize. But basically, you have this whole reservoir system that it pumps around, and the water goes into your GPU as well as your CPU, and all that kind of stuff that we talked about in the CPU cooling. So again, not something I recommend, especially if you're budget conscious. This is really expensive to do for the GPU and the CPU. And again, you run the risk of stuff leaking and all sorts of other things. So I don't really think this is the best thing for most people. And quite frankly, if not anyone, unless you're doing some really extreme overclocking and you just really like the aesthetics of this type of thing and are willing to spend the money for it. RAM, or random access memory, is the component which allows your computer to access information across software. It basically helps you work efficiently inside of multiple programs, allows you to build more complex environments or objects inside of 3D programs, and increases your efficiency in using high detailed brushes in GIMP or Photoshop. The amount of memory it can have or hold is referred to in general as a number of gigabytes. So if we look at this website here from Crucial, which makes a lot of high end or decent quality RAM sticks, you can see here that in these specifications here, they say right here 32 gigabyte kit, 2 times 16, meaning that there are two sticks, each with 16 gigs of RAM on each. Now, the amount of RAM that you need really just depends on what you plan on doing. If you're brand new to all this stuff and you're not really sure if you're going to continue in doing this professionally, and you really just want a base build of a computer to do a lot of tutorial projects and smaller projects, 16 gigs of RAM will be fine. But if you want to make it more optimal for inside of Blender and working in 4K and across, let's say, two or three different very memory hungry is usually what's referred to when talking about software and RAM, like Blender or Natron for compositing, or you're talking about other Adobe products open at the same time and you're going between them. 32 gigs is really kind of uh, it's a really nice place to be in because you won't run into any issues where your computer starts becoming slower when going between these different programs. The other thing is that what can eat up a lot of your RAM is if you have really high detailed meshes and you're doing a lot of high detailed sculpts and things like that inside of Blender or other programs. So having a good amount of RAM is a thing to look at. So 16 for sort of like the beginner who is looking to buy a new computer and get a good amount of components or good quality components with enough to sort of build out your first couple years in learning this technology and developing your skills and even doing professional projects. But you might want to throw in more RAM as you go along. The next thing that I will talk about is right here where it talks about DDR. So, just in terms of me talking to you guys about this stuff as plainly as possible, what the acronym means is double data rate, and really just understand that DDR and then a number at the end, that's really just the generation of RAM. So if you have DDR3 or DDR2 or something like that, it's just kind of like a designation of what sort of like is the newer one. So DDR4 will be generally faster and more up to date than DDR3. Are they better or worse? It really depends on price point and all that kind of stuff. So just know that DDR usually refers to sort of like the or the DDR with the number at the end really just refers to sort of the uh, generation that's being developed. So the next thing that we'll talk about here is right here it says non-ECC. So ECC means error correcting. Now we do not need error correcting RAM because really it's not really necessary for what we're doing. I would say that even as a, mid to higher professional, having error correcting RAM isn't really necessary. You could get away with having non ECC RAM. So, really, for you guys who are building these as newbies or whatever, or looking at specs for new computers, having a non ECC RAM is totally fine. You do not need error correcting RAM for the purposes of what we will be going over in the courses and the tutorials that I'll be leading. The next thing that you'll see is this number. So you'll see right here, even in the title of this right here, it says DDR4, which we already went over, and then there's a 4-digit number here. This is basically the speed of the RAM sticks. And the higher the number, yes, the faster. But sometimes that doesn't matter. So in the realm of RAM, if you're looking at a 2666 here or 3000 or 3200, like what I have in mine, I have a 3200 speed RAM in my build. Really, you don't you don't really need higher RAM. There's not that much of a speed difference between the two. If you had to do a trade-off, so if you look here at the price, so here's 129.99 for 2666, okay? And you go down the list, you see right here right away, it's more. It's what is this? $20 more? So it's $20 more just for, a little bit more speed. And really, if you get to a point where you're going like, oh, I can either have, let's say, 32 gigs of 2666 or 2133 or something like that for RAM, as opposed to 16 gigs of faster RAM, you'll want to go with the more RAM at a lower speed. Just because the amount of RAM, that 32 gigs of RAM, you will be able to perform uh, the types of things you'll need to do inside of the programs we're talking about better with 32 gigs of RAM versus 16. So if you do find yourself in that situation, a trade off between the two, lower speed RAM, but more versus less higher speed RAM, go with the lower speed, uh, more RAM. Hopefully that made sense to you folks. The last thing I'm sort of going to go over rather quickly is the DIMM acronym, which you'll see when RAM is referred to on motherboards and things like that. And really, all DMM means is dual inline memory module. So, very simply put, you see there's two inline little strips of where the input is here, and it's a module. So that's really all that means. So dual inline memory. One more thing I'd like to talk about when it comes to your RAM and why you see these in twos, packs of twos, and even sometimes packs of four. Let's see if I can find one here. That's a 4-pack. I could probably find one if I do some searches, but you'll find that a lot of times RAM is provided in these dual sort of kits. See here it says 32 gigabyte kit 2 times 16. Now, why is it two and not just one large 32 gigabyte RAM stick? The reason why is that a lot of, if not most, CPUs, especially newer ones, support dual, triple, or quad channel RAM setups. So you actually are going to be much more efficient having multiple RAM sticks in there rather than one that is larger. So, for example, this 216 that makes a total of 32 will be more efficient in a dual channel system than one single stick. Now, you will be limited based on whatever the motherboard is that you have. There are motherboards that only have one slot for your RAM, and there's some like mine that have 8 slots to put in your RAM sticks. So it really just depends on what you're trying to do. Thank you for watching this part 2 to understanding your computer. Stay tuned for part 3, where we talk about more of your computer components. Make sure to hit the like button and subscribe to this channel if you like the content here. And make sure that you hit the bell so that you get notifications when new videos have been released. And I will see you in part 3.